Okay, let's say we want to do a confidence interval based on the average weekly sales. And I'm going to use a T, which why am I going to use a T? Because I do not know the population standard deviation was not given. As you'll see that as your sample size gets large, meaning over 30, and the sample size is actually 50, probably not a big difference, okay, than your critical values with your T and Z, but because I was not given the population standard deviation, I'm going to use a T. So I can see that there's a lower limit and an upper limit for my interval. I need the sample mean. I need the T critical value. Hopefully you watched my critical value video. I need the sample standard deviation, and I need the sample size, which is n. So I already know that's 50, and I can find the mean by using the average formula and average these 50 values. And I might, well, I guess it depends because here they're not showing decimals, but if you add decimals, you'll see that that's not exactly the number, but I'll leave it in the same format as they left it. Standard deviation of my weekly values. And then, and of course, all of these are in dollars. And then my critical value. So you either use a table, or I showed in or I mentioned, I forgot to show it in the video, but I mentioned you can use the T inverse dot two tail. Now, if you don't have this one, you can see there's a T inverse. You just have to be sure to add that half piece. And again, the half piece will make sense if you watch the video. Oops, but two tail, my probability, which actually this is something I might want to put in a cell. My confidence, I want 90%. That way I can just change this number. And so my T dot inverse dot two tail, my probability is going to be 1 minus the confidence. And then remember, degrees of freedom is the sample size minus 1. Okay, so that's my T critical. Remember, this value is 1 minus the confidence. So in other words, it's 0.10. And then the degrees of freedom is found by taking the sample size minus 1. All right, so looking at this formula, it's important that you understand this piece. So how you find any confidence interval, doesn't matter if you're doing around the mean, a proportion, if you're doing a Z, a T, it's always the sample statistic plus and minus the margin of error. And the margin of error, and you're going to see why I'm showing you this piece is worth noting, is found by, just look here at the formula, your T critical times your standard deviation divided by the square root of your sample size. And they call that the margin of error because you're doing your sample plus and minus the margin of error. And I get this value here. The reason that I showed you this is there is actually a formula you might see called confidence, and notice the norm there, but I'm doing a T. Notice what it wants, alpha, which alpha is 1 minus my confidence. It wants my standard deviation because being a T, you have to use the sample standard deviation. And then it wants my sample size. So the confidence dot T, a lot of times students will see this and they'll go, oh, well, I don't need to use this formula up here. But notice what it gives you. It only gives you the margin of error. So you still have to find your upper and lower values. So we'll say lower limit, upper limit by taking your sample mean minus your margin of error and your sample mean plus your margin of error. And once again, if you want to put these probably correct all in dollar amounts, since they say these are sales, but then that gives you, if I went out and took 100 samples, I would expect 90 of them, because of my confidence, 90 of them to be within this interval. And so now if you set this up, correctly with your formulas, you could just change 95, see what happened there. You could change your sample size, say to 100, see what happens. But once you set this up for your confidence interval, then all you have to do is just change these actual values.